Apophis, officially known as 99942 Apophis, is said to make a very close pass by the Earth. On April 13, 2029, this asteroid will come so near that it will actually pass between Earth and some of our communication satellites. To put it into perspective, Apophis will come closer to us than the moon's orbit. With the size of about 3 football fields, this asteroid will be a breathtaking sight as it passes by, coming within a distance of about 19,000 miles from the Earth's surface. This celestial event serves as a wake up call, highlighting the need for the measures to potentially deflect such asteroids in the future. So let's explore the techniques we can use to mitigate the potential dangers of such close encounters. Imagine a spacecraft hurtling through space at an incredible speed, aiming to collide with an asteroid. This bold approach is known as the kinetic impactor method. When the spacecraft impacts the asteroid surface, it transfers a significant amount of momentum to the asteroid. This transfer of momentum acts like a gentle nudge, changing the asteroid's trajectory over time. The goal? To steer the asteroid away from Earth's path, thus avoiding a catastrophic impact. One of the real-world examples of kinetic impactor would be the DART mission conducted by NASA. DART aimed to alter the orbit of the small moonlet Dimorphos, which orbits a larger asteroid named Didymos. DART's collision with Dimorphos occurred at around 14,000 miles per hour, slightly slowing the moonlet's orbital speed, about 1% reduction in its orbital length, which is equivalent to about 10 minutes. Picture this: a spacecraft strategically positioned alongside an asteroid, relying on the gentle pull of its own gravity to gradually change the asteroid's trajectory. This technique does not involve violent impacts or explosive forces. Instead, it's a dance of gravitational attraction over a prolonged period. This method is known as the gravity tractor approach. For the gravity tractor approach to work, the spacecraft must maintain a specific distance from the asteroid. This distance can vary, but is generally within a few kilometers to a few tens of kilometers, depending on the size of the asteroid and the spacecraft's capabilities. Over time, the accumulated change in velocity due to the gravitational interaction can lead to a significant shift in the asteroid's path, potentially enough to avoid a collision with the Earth. Next method sounds like it comes straight out of a science fiction movie, using nuclear explosions to alter the path of an incoming asteroid. The immense energy released by the explosion could create a force that nudges the asteroid off its collision course, sparing our planet from a catastrophic impact. But the nuclear deflection technique is filled with controversy. Detonating a nuclear device in space could lead to the fragmentation of the asteroid into smaller and potentially more dangerous pieces. Even determining the optimal distance to detonate the device and the asteroid's composition makes this technique even more complex. Another technique proposed by scientists was deflecting an asteroid by focusing solar energy onto it using an array of mirrors. Similar to the nuclear explosion technique, this would generate propulsion through vaporizing the surface matter of the space rock. The mirrors would have to be installed in a ring array that positions the focal area in such a way that it prevents the target from blocking the sun's rays or coating the mirrors with ejected debris. Another technique to avoid collision would be breaking up the asteroid into smaller and less hazardous fragments. By shattering the asteroid, we can potentially change its trajectory or ensure that smaller fragments burn up harmlessly in our atmosphere. However, there are risks. Fragmenting an asteroid might create a shotgun effect, where a barrage of smaller impacts occurs across a larger area. One way to fragment an asteroid involves using kinetic impactors. By sending a series of smaller spacecraft to collide with the asteroid surface, we can generate enough force to break it apart. Each impactor creates a controlled explosion, resulting in a controlled fragmentation pattern.